Thank you very much. Again, just to reintroduce myself, Roger Soto. I've had the pleasure of working on this tower now since I think about 8, 9 years ago that we started on this with my partner, Mr. Bassem Shihabi, who's sitting here, of Omrania. This was a very well-integrated team, and I think the results are outstanding. I hope you share that impression with me today. I'd like to also just acknowledge that Omrania was not only an architecture partner, but also an engineering partner on this project, providing structural services and MEP services. In addition, Hyder was a structural engineer for us, and WSP Flack and Kurtz helped with the MEP. I see Anton in the audience. Thank you. Anton provided the wind tunnel analysis for this tower, as he usually does exceptionally well. So let me start by saying that the King Abdullah district in which this tower is located is really an amazing urban development in Saudi Arabia. I'm not sure there's anything quite like it, and it really is an attempt to create a multi-phase mixed-use project that will become a world-class financial center for the Kingdom of Saudi Arabia and the entire region. This project is located on the north side of Riyadh on about 1.6 million square meter site. Contains about, when it's fully built, I think it will contain in excess of 3 million gross square meters of construction. And it is the intent that this will attract major financial services sector companies and really position Saudi Arabia's capital city as a leading financial and economic nexus in the Middle East. Some of you who may be familiar with Riyadh know that the bulk of the development occurs along King Fahd Road, and on which are located some iconic structures which have been there for a long time. And the KFAD district becomes a kind of a new northern downtown area for the city, of which our project constitutes one of the central elements. The urban planning for KFAD was accomplished by Henning Larsson, who is, I'm pleased to say, I'm sharing this podium with today. And really, it's a very outstanding and interesting urban plan, really quite different from many of the projects we've seen, really responsive, I think, to the climatic conditions, to the tradition of urban development in the region, and I think inspired by the notion of using nature, geologic forms as a way to begin to create a fabric of buildings. It contains a conferencing center, it contains office buildings, residential buildings, hotels, mosques, cultural facilities, museums. And when completed, the district will employ about 75,000 people. The centerpiece of this development, you can see some of the photos of the project under construction. It is really an amazing, outstanding endeavor of tremendous complexity. The centerpiece of this development is the Capital Authority Tower. It is the tallest of 5 buildings that make up the community's financial plaza. It is 385 meters tall, and it has 73 occupied floors for a total of 76 floors, a gross area of 182,000 square meters. The building's anchor tenant is the Capital Market Authority. The tower design responds to the constraints of a very interesting and unusual site. By the way, these are pictures of the tower under construction recently taken about, I'd say about 3 months ago. This is a view of the tower from the ground, looking up in the surrounding buildings that make up the financial plaza. This is the site on which the tower was built, and as you can see, the dotted line represents the actual limits and borders of the site. So what's interesting about the urban development is that it really produced a lot of constraints on how we could position buildings. This is not about buildings that exist in a kind of open space vacuum. This is about buildings that are very tightly compacted together, so each individual site was actually quite restricted. There were a lot of design guidelines that affected the site, such as podium height, podium location, building height, materials, sustainability. They all came to play into the design of the building. The design of this floor plate, as you can see, what we eventually came to regard as the ideal design was a hexagon that fit into the eastern portion of the site. And you can see how that hexagon really follows very closely the geometry of the site conditions that we were dealing with. The hexagon consists of these 6 sides, and between each 6 side is a section of the building that we call a pleat. The geometry of the building, as you will see, helped us to modulate the building in such a way that we could create or maintain regular modules throughout the office floors. So we wanted to make the floor plate clear, span, least steps. We wanted to allow flexibility, efficiency. We wanted access to natural daylight. And so this natural shape emerged, which also tapers inward and outward as it rises. And the floor plates provided range from anywhere from 2,500 to 2,600 square meters of gross floor area. So the result of the plan and extrusion of that plan and that concept vertically is a faceted-like, crystal-like structure that acknowledges a desire to create a memorable image inspired by, again, the idea of geological formations. This language also applies to the podium structure, whose faceted planes and shading elements provide a constantly changing view from the ground. Now, the structure, as it comes down to the ground, merges, all the basic columns of the structure merge as they come down to the ground into 6 mega supporting columns, which provide much more openness on the ground level. The service functions are located below grade and accessed by a system of below grade service streets. And then the podium contains a series of functions that support the building as a whole. Now you will see that in section, the tower is divided into 3 parts, 3 sections, low, mid, and high, with 2 sky lobbies, mechanical systems in between each of those components. The upper portion of the tower is occupied by the anchor tenant, with an observatory at the top deck. The tower is all office space. So this is not a mixed-use tower. This is a dedicated office tower completely just for that use. So you can see here in this rendering the way that the facades on the hexagonal shape move in and out of the building's shape, and then you can see the way the pleat manages to intersect those planes together as the tower rises. You'll see the financial plaza located right here at the bottom of the building. From that financial plaza, we have vehicular entrances as well as entrances from the exterior perimeter road that service the tower. Now, it is important, and I think quite critical, when you design an office building, that the floor plates are rational and that they can accommodate the variety of uses. In this case, the notion was that about 1/3 of this tower would be multi-tenant, 1/3 would probably be single floor, and the last third would be occupied by one single tenant. So we really had to test at multiple floors how the tower laid out. Of course, the core keeps itself in a very similar geometry, but as the tower rises and tapers inward and outward, the shape changes. Now you can see we tested every individual floor to make sure that in fact the flexibility was there for multi-tenant or single tenant. In this case, this is a typical multi-tenant floor. This is another multi-tenant floor but with less tenants, and this is a single occupant floor. Now, we couldn't really achieve the kind of core that you saw without using the technology of elevators that we used here for this building. You know, when you're dealing with a tower that's only 2,600 or 2,500 square meters, you're not dealing with a very big floor plate for a super tall building. So a lot of the issues that we had to deal with had to do with how can we fit the vertical transportation into this core. And so we really looked at the technology of using twin elevators for this particular application, and that's what is being installed today. As you can see from the diagram, the way we used it and applied it is that we provided express elevators, dual deck express elevators to the lobbies. And from there, we provided local elevators using the twin system. So the twin system is in blue for every local floor, and the express elevators are in red. Now to understand the impact, when we first started on the project and we're not considering using the twin elevators, you can see to the left, the diagram contemplated actually putting the express elevators on the exterior of the core in a spoke-like pattern. Once we did the study and analyzed it and looked at using the twin, we managed to actually contain everything within the core, as you can see. A very, very significant effect on the overall efficiency and flexibility of the building. I'd like to walk you through the podium design. The podium is geometrically very similar to the tower. It's conceived as a kind of a gemstone that's leaning against the tower. It integrates public circulation and amenity spaces. There are multiple functions in the tower, in the podium, that I'd like to bring to your attention. Of course, there's the lobby, sorry. Let me go back here. There's the lobby space, which, as you can see on the left, is a tall, sort of canyon-like structure. You can see the mega columns in this view coming together into one tripod arrangement. The lobby to the right side, the podium to the left side, with a installation, an art installation on that wall. A view of the observation deck at the upper level. And then on the podium itself, a view of the dining facilities on the upper level, and a auditorium facility located on the lower levels of the building. So I want to talk a little bit about the enclosure system for the building. This is a close-up view of the exterior enclosure system. As you all know, who practice in the Middle East, we have a very harsh climate to deal with, and this is a difficult problem. The difficulties, of course, is that when you do a super tall, there's an expectation to have views to the outside. And of course, having views to the outside means lots of glass. And that is counterproductive in terms of radiant heat load, which is a problem. So in Riyadh, we get the typical condition of glass towers where they are covered with blinds, so that we then use artificial lighting. So we get both the radiant heat and we get the artificial lighting as impact. So we had to come up with a system that created a way to shade the building and yet still provide views. And we spent a lot of time working on this particular system. The other issue that we have in Saudi Arabia, as you probably also know, is the question of dust. And the accumulation of dust on buildings is quite severe, especially during the sandstorm season. So we have a maintenance issue, a building maintenance issue. It's not good to have these glass towers in Saudi Arabia and see them over time just become dusty before you can clean them. So what we decided to do was to try to create a system that addressed both these issues with one move. So our system, basically major components consist of a triple glazed wall, IGU, which is an unitized system, a horizontal gantry or catwalk that's located on every floor, an array of angled glass fins that are connected to the gantry for shading, a photovoltaic farm on the crown of the building, and a custom building maintenance unit system that is used to maintain and clean the building. So what we had to do, in essence here, was work on a way to integrate all of these things into one thing. So we have an exterior shading system here that is both fins and walkways. So as you probably all know, the best way to shade a building typically is a kind of an egg crate design, horizontal and vertical. In our case, what we decided was to use both of those strategies, and the vertical system consists of these glass fins with a frit pattern on it. The horizontal system consists of the grate, which also provides access for maintenance as well on every floor. In addition to that, our IGU system is a 3-layered glass unit, a clear glass on the inside, and then 2 layers of Solar Band 70 XL, one on top of the other. Some details that we developed as we looked at the catwalk system. Most of these elements were pre-fabricated, brought to the site, and installation allowances in order to align all the fins so that they would all be true and angled in the proper angle. Now, mind you, all of these fins are actually angled optimally on each side as we move around the tower. So in plan, these fins are actually on an angle, but they are on different angles depending on where you look on the tower. The access system for the tower includes a monorail that allows you to carry heavy objects such as replacement glass that can be brought in, and it also includes a rail for a bucket that can be used to maintain supplies to clean the facade. So on top of the roof, we have 3 large BMUs that are able to luff up over the top of the crown and also bring down through the pleats of the building. They bring down the platform on which workers can go down to the lower levels. These BMUs can also service and help to maintain cleanliness on the photovoltaic array system as well. And you can see how the pleats themselves become the vertical means by which we access all of these different platforms. So we custom designed this platform so that at every level there is a movable gantry that allows people to get out onto the catwalk from the platform. And then the edges of the pleats basically contain the edges of the catwalk system. The PV array is set up at the top of the building and provides about 1% of the total energy of the project. And you can see here a study model of the top of the crown of the building and how that was arranged, and a current view of the crown of the tower under construction, reaching completion. Another quick view of the podium. I'm sure many of you were wondering when you saw that cafeteria image, how could we wind up with a glass ceiling on the cafeteria? So let me just walk you through that. Really, the whole podium is also covered by a shroud. It consists of 3 layers of coverage. The actual structure of the building itself is a simple slab with columns, but the exterior structure is a diagrid structure on which then sits another overstructure that holds a system of metallic shade covers. We came up with a name for them, all these metallic components, we call them kites. And these kites are pleated so that we can allow natural light and filter it through the top of the building. You can see the layering system here of the cover that goes over the podium. In addition, there is a nanogel aerogel on the glass unit. So in addition to the 3 unit IGUs, we also have the nanogel system in the glass. And these are just some studies that we did to look at the ways in which we could design the kite system and how much they would pleat, depending on solar orientation. Again, a mock-up of that kite and the actual installation of that kite now going on in the building itself. So, I think my time is almost up. I will conclude with a couple of comments. One is, the building is aiming for LEED Gold at the moment, and one of the important components, of course, is energy usage. The master plan required us to meet a 50% of average Riyadh, below average Riyadh building stock, or about 500 kilowatts per square meter per year. That meant that we had to be at about 92,900 megawatts per annum. We are right now sitting on 44,000, and so that means that this building will consume only 24% of the energy of an average Riyadh building. That's something that we're really quite proud of. So, as one of the world's tallest and most advanced commercial structures, I think the CMA Tower is making a profound statement about Riyadh, about Saudi Arabia as the financial capital of the Middle East. The building also advances an iconic design that effectively addresses the region's climatic and environmental challenges through creative and unique technical solutions. And its signature role in the King Abdullah Financial District, high-performance integrated enclosure system, flexible interior environment, and innovative vertical transportation system, I think will serve as an influential global benchmark for super tall buildings.